Welcome back, Math Analysis. We're going to do review number 4 on solving inequalities and putting the answer in interval notation. I know that this is definitely a review topic that you've learned before, so we're going to cover it rather quickly. We're going to talk about just interval notation, solving inequalities, and then at the end we're going to do some compound inequalities where you have to separate them. And we'll just get started. So interval notation is one way of expressing the answer as opposed to set notation. And so what you're normally used to seeing, like right here where it says x is less than 3, in the past you likely have drawn this on a number line. You might have used this parenthesis. You might have also done an open circle going to the left. Interval notation is sort of saying what is the range or area where x could be in, what interval. And so on the left is negative infinity. The arrow goes all the way to negative infinity. And so what we have for this interval notation is we have our left boundary, and so there is no left endpoint. It goes forever. It goes to negative infinity, and it can go all the way up to 3, but not including 3. So this is your right boundary. And then if you can't equal 3, being less than 3 could be like 2.9, 2.9999999, but never 3. We use an open circle to show it's empty, but in interval notation we use a parenthesis to show that you can't equal that endpoint. So it's all the numbers that are between negative infinity and positive 3, but not including positive 3. In the middle, it's similar, but now it's x is greater than or equal to negative 2, so it's the other direction. It goes to positive infinity. You'll notice that right here on the right side. But because you could be greater than or equal to negative 2, now negative 2 gets a bracket because you can equal negative 2. So brackets are when you can equal that number. Brackets include the endpoint. Parentheses don't include the endpoint. You can also have an inequality like this, a compound inequality, where x is between negative 4 and 9. And so x can be on the left, negative 4, and x can be on the right, positive 9. Notice it's less than or equal to 9. So to show it can equal 9, we put a bracket. Since it can't equal 4, it has to be greater than 4, we use a parenthesis. And so we'll just move on, but hopefully that was a quick review of interval notation. So when you're solving inequalities, you're always going to express the solution in interval notation. And so just to really quickly solve number 1, everything is going to be the same as solving a normal equation. You'll distribute, you'll combine like terms, you'll get x by itself. There's only one rule, and you're going to see that on number 1. And that's whenever x is negative, you'll eventually divide by a negative number. You must switch the direction of the inequality symbol. Again, when you divide by a negative number or you multiply by a negative number, you have to switch the direction of the inequality symbol. And so for number 1, we're going to start by distributing negative 4. And everything else is going to be the same. Then we're going to add 12 to both sides. And so you get negative 4x is less than or equal to positive 28. So notice I haven't switched the inequality symbol. It's because I'm going to do it on this very next step. It's when I divide by negative 4 to get x by itself. Now I need to flip the inequality symbol. So from this symbol to this symbol, we're going to flip its direction. So it's going to be x is less than or equal to negative 7. Okay? Whenever you divide by a negative number, that's what you need to do. Otherwise, we would never do this. And so to put this on a number line, you can easily just draw a number line with negative 7 as the middle. And normally what you would put is if you're using circles, you do a shaded circle going to the left. The interval notation for this is on the left, negative infinity. That's the left side, and the right side is negative 7. And so the answer is negative infinity with a parenthesis always for infinity. And then negative 7 gets a bracket because we can include negative 7. That's it. The answer is in interval notation. Moving on to the right side, we're going to do essentially the same thing. We're going to start by distributing. And so we get 2x plus 6. Now I'm going to put x on the same side. And by the way, I'm going to subtract 2x to move 2x to the left side. But something weird happens here. This is kind of a weird situation. If 2x gets subtracted on both sides, it cancels out. And that's That usually doesn't happen. And so I get something left over that looks like this. -5 is less than or equal to 6. If this happens, there's no x anymore. That means it doesn't matter what x equals. Is this inequality going to be true, or is this inequality going to be false? It's going to be true. -5 is always less than or equal to 6. And so, does it matter what x equals? No, because this inequality is always true. And so, I'll write down the x canceled out, and the inequality is true. Okay? And so, this right here is always true no matter what. So the answer is really all real numbers from -infinity to infinity. It doesn't matter what x equals. Okay? Any value you plug in for x would still make that inequality true. There's nothing you can plug in for x that would make it not true. And so the answer is all real numbers or -infinity to infinity. If it was false, you'd put no solution. And so I'm going to make a little small note. If false, oops, okay, that was bad. If it was false, sorry about that spelling, there'd be no solution. That'd be this symbol, the empty set, okay? So if it was false, you'd say there's no solution. But since it was true, the answer is all real numbers. All right, so that's just basic simple inequalities. I want to move into compound inequalities. And this is what a compound inequality looks like. You're going to see two inequality symbols, one right here and one right here. Something like this one, where the variable is in the middle and there's no other variables, you can solve it two different ways. You could solve this one if you wanted to just by subtracting 1 from the left, the middle, and the right. And then you'd get -6 is less than or equal to 2x is less than 8. Then you divide by 2. And you end up getting -3 is less than or equal to x is less than 4. And so the inequality, interval notation is from -3 to 4. Okay. That's one way of solving this. There is another method that you could use, and that's where you break it into separate inequalities. And so what I'd like to do is I'd like to demonstrate this same problem, another method that looks like it's more work, but it's going to be required if you're going to solve this, the next problem. So another way of doing this, instead of breaking it or just leaving it as one compound inequality, is to separate it into separate inequalities. So -5 is less than 2x plus 1, and, for intersection, 2x plus 1 is less than 9. And so you have basically two inequalities. And so really you're looking for when are both of these going to be true at the same time. And so really all you have to do then is you separately solve each inequality. And so here you could take away 1, and you get -6 is less than or equal to 2x. You divide by 2, -3 is less than or equal to x. I like to write it in the order where x is first. And notice that if this is the inequality that it's opening towards the x, if you switch the order around, keep it opening towards x. So x is greater than or equal to -3. Over here we solve it the same way. We just subtract 1. We get 2x is less than 8. Divide by 2, x is less than 4. And so you don't have to worry about switching this around. So it's really x is greater than or equal to -3 and x is less than 4. And so if you picture the number line, if you were going to solve this with a number line, if I made a -3 here on the left, it's a smaller number, and a +4 here on the right, I would want to find values where x is both greater than or equal to -3, and at the same time, x is less than or equal to +4, excuse me. And so where it overlaps, where it intersects, is from -3 to 4, is where it overlaps. It includes -3, so you really would say it's from -3 to 4, like this. Same answer as over here, just another way of doing it. So you have two options. Both of them are correct. The way you see it on the right is actually how we're going to solve the next problem, and so that's why I showed that to you. So if you see one variable here in the middle and there's no other variable, you can solve it the way I did on the left. It's much faster. Or you can separate it into separate inequalities the way I did it on the right. However, we're going to move on. If you notice, number 4 looks crazy because there's a bunch of variables all over the place. You see an x on the left, you see an x in the middle, you see an x on the right. You have to separate this into separate inequalities. You can't do it the original way. And so if you solve it this way all of the time, that would be great. You could separate the left inequality on its own and the right inequality on its own. So we're looking for where the two solutions overlap. So we have just a left side inequality and a right side inequality, and we just, again, broke it apart. And so again, to solve this, I'm going to subtract 2x. I like to put x on the left, and that means I'm going to take away 1 on both sides. And I'm going to end up getting negative x is less than or equal to negative 4. I divide this by negative 1. Remember, I flip the inequality symbol if this happens. I get x is greater than or equal to 4. Over here, I subtract 3x, and I would add 3 to both sides. And so I get negative x is less than negative 2. Divide by negative 1, and I end up getting x is greater than positive 2. And so where is x greater than or equal to 4 and x greater than 2? That's going to be my solution. And so again, I like to sketch a number line, just kind of visualize this. I know that the number 2 is less than 4, so it's going to go on the left. And so I've got one interval where x is greater than or equal to 4, so a shaded circle at 4, going to the right. And the other interval is actually also going to the right. I'm greater than 2, so I use an open circle going to the right. Both arrows go to the right. Where do they overlap? They overlap anywhere you're greater than or equal to 4, all the way to infinity. And so the answer is from 4, including 4 in a bracket, to infinity with a parenthesis always. That's the solution of the entire inequality. If you plug in the number 4 for x, you should see that this inequality is true. If you plug in any number larger than 4, this inequality on the top would still be true, but no other values would work. Okay, so again, we're looking at where do they overlap. Okay, the solution is where the two inequalities overlap. I'll even write that down. So the solution is where both inequalities overlap. Okay, where you see them both graphed. All right, I know it's been 4 examples. We're going to do one more like this because I think this one's a little bit confusing. If you're still needing more help, again, please ask me during class, or we can also just have you look online and see some more examples. So this is number 5. Notice again, there's more than one variable. It's not just in the middle. So we're going to go ahead and separate this into the left side and the right side. So x is less than x plus 1. Over here I have x plus 1 is less than 3x minus 7. The word and or intersection can go in the middle to say they both need to be true. Now, the left side, if you think about this, x is less than x plus 1. I think that's always going to be true. Here's how it's going to happen. You take away x on both sides. Let's say you're not really thinking about what you're doing, you're just following the steps trying to get x by itself. Well, x cancels out. And so what you really get is 0 is less than or equal to 1. This is always true. Okay? No matter what, 0 is less than or equal to 1. Okay? On the right, I'm going to subtract 3x. I'm going to also subtract 1. I'm going to subtract 3x, subtract 1, just to kind of rearrange things. I get negative 2x is less than negative 8. I divide by negative 2. Remember that x is greater than 4. You're going to switch that inequality symbol because you're dividing by a negative number. And so on the left, the answer here is really negative infinity to infinity. It's always going to be true. So if I were going to draw a number line, okay, and I were to put the number 4 right here, This one, if I were to graph it, is just going to be an open circle at 4 going to the right. This one, if I wanted to graph it, it would just be an arrow that goes from the left all the way to the right, from negative infinity to infinity. I don't know why I made that one black. Let me kind of change that color. Let's say I do this one in blue. This one goes all the way to infinity from negative infinity. You're just looking at where are these overlapping. And so it looks like they overlap starting at 4, but not including 4, all the way to infinity. Again, that's the overlap. So the overlap is the answer. And you might ask, well, what if I ever had a problem where there was no overlapping part? If there was no overlapping part on a different problem, there'd be no solution. So again, when you see a compound inequality, when there's more than one variable, just separate them into 2 separate inequalities, solve them both independently, and see where do the 2 solutions overlap. All right, that's it for interval notation. Hopefully this has been a good review.